What's up? Welcome back. My name's Matthew. We're going to be going over the client-server overview. Now that you know the purpose and potential benefits of server-side programming, we're going to examine in detail what happens when a server receives a dynamic request from a browser. As most websites, server-side code handles requests and responses in similar ways. This will help you understand what you need to do when writing most of your own code. So some prerequisites: basic computer literacy, a basic understanding of what a web server is, which we went over, and then the objective of this lesson is to understand client-server interaction in a dynamic website, and in particular, what operations need to be performed by a server-side code. There is no real code in the discussion because we haven't yet chosen a web framework to use to write our code. This discussion is, however, still very relevant because the described behavior must be implemented by your server-side code, irrespective of which programming language or web framework you select. Web servers and HTTP, a primer. Web browsers communicate with web servers using the Hypertext Transfer Protocol, HTTP. When you click a link on a web page, submit a form, or run a search, the browser sends an HTTP request to the server. The request includes a URL identifying the target server and resource, example, an HTML file, a particular data point on the server, or a tool to run, a method that defines the required action, for example, to get a file or to save or update some data. The different methods / verbs and their associated actions are listed below. So a get a specific resource, example, an HTML file containing information about a product or a list of products. Post, create a new resource, example, add a new article to a wiki, add a new contact to a database. Head, get the metadata information about a specific resource without getting the body, like get would. You might, for example, use head request to find out the last time a resource was updated, and then only use the more expensive get request to download the resource if it has changed. Put, update an existing resource, or create a new one if it doesn't exist. Delete the specific resource. Trace, option, connect, and patch. These verbs are for less common / advanced tasks, so we won't cover them here. Additional information can be encoded with the request. For example, HTML form data, and information can be encoded as URL parameters. So get requests encode data in the URL sent to the server by adding name / value pairs onto the end of it. For example, http example.com, name equals Fred, and age equals 11. You always have a question mark separating the rest of the URL from the URL parameters, an equal sign separating each name from its associated value, and an ampersand separating each pair. URL parameters are inherently insecure as they can be changed by the user and then resubmitted. As a result, URL parameters / get requests are not used for requests that update data on the server. Post data. Post requests add new resources, the data for which is encoded within the request body. Client-side cookies. Cookies contain session data about the client, including keys that the server can use to determine their login status and permission / accesses to resources. Web servers wait for the client request messages, process them when they arrive, and reply to the web browser with an HTTP response message. The response contains an HTTP response status code, indicating whether or not the request succeeded. Example, 200 OK for success, 404 not found if the resource cannot be found, 403 forbidden if the user isn't authorized to see the resources, etc. The body of a successful response to a GET request would contain the requested resource. When an HTML page is returned, it is rendered by the web browser. As part of the processing, the browser may discover links to other resources. Example, an HTML page usually references JavaScript and CSS files, and will send separate HTTP requests to download these files. Both static and dynamic websites, discussed in the following sections, use exactly the same communication protocol / patterns. Get requests / response example. You can make a simple get request by clicking on a link or searching on a site, like a search engine homepage. For example, the HTTP request that is sent when you perform a search on MDN for the term client-server overview will look a lot like the text shown below. It will not be identical because parts of the client message depend on your browser / setup. Note: the format of HTTP messages is defined in a web standard, RFC 9110. You don't need to know this level of detail, but at least you know where this all came from. The request. Each line of the request contains information about it. The first part is called the header and contains useful information about the request, in the same way that an HTML head contains useful information about an HTML document, but not the actual content itself, which is the body. The first and second lines contain most of the information we talked about above. The type of request, GET, the target resource, URL, en-us search, the URL parameters, the target / host website, developer, mozilla.org, The end of the first line also includes a short string identifying the specific protocol version. The final line contains information about the client-side cookies. You can see in this case that the cookies include an ID for managing sessions. The remaining lines contain information about the browser used and the sort of responses it can handle. For example, see here that my browser user agent is Mozilla Firefox. It can accept gzip compressed information. It can accept the specified set of characters and languages. The referrer line indicates the address of the web page that contains the link to this resource, the origin of the request. HTTP requests can also have a body, but it is empty in this case. The response. The first part of the response for this request is shown below. The header contains information like the following. The first line includes the response code 200OK, which tells us the request succeeded. You can see that the response is text/HTML formatted. We can also see that it uses the UTF-8 character set. The head also tells us how big it is. At the end of the message, we see that the body content, which contains the actual HTML returned by the request. The remainder of the response header includes information about the response, example, when it was generated, the server and how it expects the browser to handle the page, example, the X-frame option deny. Line tells the browser not to allow this page to be embedded in an iframe and other sites. Post request/response example. An HTTP post is made when you submit a form containing information to be saved on the server. The request. The text below shows the HTTP request made when a user submits new profile details on this site. The format of the request is also the same as the GET request, example shown previously, though the first line identifies this request as a post. The main difference is that the URL doesn't have any parameters. As you can see, the information from the form is encoded in the body of the request. For example, the new user full name is set using and user full name equals Hamish Willie. The response. The response from the request is shown below. The status code of 302 found tells the browser that the post succeeded and that it must issue a second HTTP request to load the page specified in the location field. The information is otherwise similar to that of the response to the GET request. Note, the HTTP response and requests shown in these examples were captured using the Fiddler application, but you can get similar information using web sniffers or packet analyzers like Wireshark. You can try this yourself. Use any of the linked tools and then navigate through a site and edit profile information to see a different request and response. Most modern browsers also have tools that monitor network requests. Static sites. A static site is one that returns the same hard-coded content from a server whenever a particular resource is requested. So for example, if you have a page about a product at static myproduct1 HTML, this same page will be returned to every user. If you add another similar product to your site, you will need to add another page, myproduct2.html, and so on. This can start to get really inefficient. What happens when you get thousands of product pages? You would repeat a lot of code across each page, the basic page template structure, etc. And if you wanted to change anything about the page structure, like add a new related product section, for example, then you'd have to change every page individually. Note, static sites are excellent when you have a small number of pages and you want to send the same content to every user. However, they can have a significant cost to maintain as the number of pages becomes larger. Okay, let's recap how this works by looking again at the static site architecture diagram we looked at in the last article. When a user wants to navigate to a page, the browser sends an HTTP GET request specifying the URL of its HTML page. Server retrieves the requested documents from its file system and returns an HTTP response containing the documents and an HTTP response status code of 200OK. Indicating success. The server might return a different status code, for example, 404 not found, if the file is not present on the server, or 301 moved permanently, if the file exists but has been redirected to a different location. The server for a static site will only ever need to process GET requests, because the server doesn't store any modifiable data. It also doesn't change its response based on HTTP request data, example, URL parameters or cookies. Understanding how static sites work is nevertheless useful when learning server-side programming, because dynamic sites handle requests for static files, CSS, JavaScript, static images, etc. in exactly the same way. Dynamic sites. A dynamic site is one that can generate and return content based on the specified request URL and data, rather than always returning the same hard-coded file for a particular URL. Using the example of a product site, when the server would store product data in a database rather than individual HTML files. When receiving an HTTP GET request for a product, the server determines the product ID, and fetches that data from the database, and then constructs the HTML page for the response by inserting the data into an HTML template. This has a major advantage over static sites. Using a database allows the product information to be stored efficiently in an easy, extensible, modifiable, and searchable way. Using HTML templates makes it very easy to change the HTML structure because the only needs to be done in one place, in a single template and not across potentially thousands of static pages. Anatomy of a dynamic request. This section provides a step-by-step overview of the dynamic HTTP request and response cycle, building on what we looked at in the last article with much more detail. In order to keep things real, we'll use the context of a sports team manager website where a coach can select their team name and team size in an HTML form and then get back a suggested best lineup for the next game. The diagram below shows that the main elements of the team coach website, along with numbered labels for the sequence of operations when the coach assesses their best team list. The parts of the site that make it dynamic are the web application. This is how we will refer to the server-side code that processes HTTP requests and returns HTTP responses. The database, which contains information about players, teams, coaches, and their relationships with the HTML templates. After the coach submits the form with the team name and the number of players, the sequence of operations is 1. The web browser creates an HTTP GET request to the server using the base URL for the resource /best and encoding the team and player names either as a URL parameter, example best team, team my name, show equals 11, or as part of the URL pattern. Example, best/my team name. A GET request is used because the request is only fetching data, not modifying data. Number 2, the web server detects that the request is dynamic and forwards it to the web application for processing. The web server determines how to handle different URLs based on pattern matching, rules defined in its configuration. Number 3, the web application identifies that the intention of the request is to get the best team list based on the URL /best and finds out that the required team name and the number of players from the URL. The web application then gets the required information from the database, using additional internal parameters to define which players are the best, and possibly also getting the identity of the logged-in coach from the client-side cookie. Number 4, the web application dynamically creates an HTML page by putting the data from the database into placeholders inside an HTML template. Number 5, the web application returns the generated HTML to a web browser via the web server, along with an HTTP status code of 200 success. If anything prevents the HTML from being returned, then the web application will return another code, for example 404, to indicate that the team does not exist. Number 6, the web browser will then start to process the returned HTML, sending separate requests to get any other CSS or JavaScript files that it references. Number 7, the web server loads static files from the file system and returns them to the browser directly. Again, correct file handling is based on configuration rules and URL pattern matching. An operation to update a record in the database would be handled similarly, except that like any database update, the HTTP request from the browser should be encoded as a POST request, doing other work. A web application's job is to receive HTTP requests and return HTTP responses, while interacting with a database. To get or update information are very common tasks. The code may do other things at the same time, or not interact with the database at all. A good example of an additional task that a web application might perform would be sending an email to a user to confirm the registration with the site. The site might also perform logging or other operations, returning something other than HTML. Server-side website code does not have to return HTML snippets, files, in the response. It can instead dynamically create and return other types of files, text, PDF, CSV, etc., or even data, JSON, XML, etc. The idea of returning data to a web browser so that it can dynamically update its own content, AJAX, has been around for a while now. More recently, single-page apps have become popular, where the whole website is written with a single HTML file that is dynamically updated when needed. Websites created using this style of application push a lot of computational costs from the server to the web browser and can result in a website that appears to behave a lot more like native apps, highly responsive. Web frameworks simplify server-side web programming. Server-side web frameworks make writing code to handle the operation described above much easier. One of the most important operations they perform is providing simple mechanisms to map URLs for different resources/pages to specific handler functions. This makes it easier to keep the code associated with each type of resource separate. It also has a benefit in terms of maintenance, because you can change the URL used to deliver a particular feature in one place without having to change the handler function. For example, consider the following Django Python code that maps two URL patterns to view functions. First pattern ensures that an HTTP request with a resource URL of /best will be passed to a function named index in the views module. A request that has a pattern /best/junior will instead be passed to the junior view function. Note, the first parameter in the URL function may look a bit odd because they use a pattern matching technique called regular expressions, regex or RE. You don't need to know how regular expressions work at this point, other than that they allow us to match patterns in the URL, rather than the hard-coded values above, and use them as parameters in our view function. As an example, a really simple regex might say, match a single uppercase letter, followed by between 4 to 7 lowercase letters. The web framework also makes it easy for a view function to fetch information from the database. The structure of our data is defined in models, which are Python classes that define the fields to be stored in underlying database. If we have a model named team with a field of team type, then we can use a simple query syntax to get back all the teams that have a particular type. The example below gets a list of all the teams that have the exact case-sensitive team type of junior. Note the format. Field name, team type, followed by double underscore, and then the type of the match to use, in this case exact. There are many other types of matches that we can daisy chain them. We can also control the order and the number of results returned. After the junior function gets the list of junior teams, it calls the render function, passing the original HTTP request, an HTML template, and a context object defining the information to be included in the template. The render function is a convenience function that generates HTML using a context and an HTML template, and it returns it in an HTTP response object. Obviously, web frameworks can help you with a lot of other tasks. We discuss a lot more benefits and some popular web frameworks choices in the next article. Summary. At this point, you should have a good overview of the operations that the server-side code has to perform and know some of the ways in which a server-side web framework can make this easier. And the following module will help you choose the best framework for you for your first site. And that is it for this video. Thanks for watching. I'm going to be continuing with Express as a web framework because that's what I'm learning. So that's going to be the next video. Thanks for watching. Bye.